Hi, I'm going to discuss the answers to the questions in Term 1 System-Wide Quiz in this episode of Physics is Easy with Mr. Jesse. First question, how long does it take an object to slow down from 34 meter per second traveling east to 13 meter per second east if it is an acceleration of 3.0 meter per second squared to the west? So basically we are given the following: vi, initial velocity, and this is our final velocity, and this is our acceleration. That's our acceleration. So the object is actually slowing down, as you can see also in the values of the final and initial velocity, and we are asked how long. So basically it's asking us to solve for time. How long does it take? So the equation of motion that we're going to use is equation number 1, which is Vf is equal to Vi plus at, mainly because we are given final velocity, we have initial velocity, we have acceleration, and we need to solve for the time. Right, so let us substitute our values. Our final velocity is 13, and that is equal to the initial velocity, which is 34, plus the acceleration. And since the object is moving to the east, but the acceleration is to the west, then therefore our acceleration is negative 3 meter per second square multiplied by the time, which is what we need to solve for. So what do we do here? We simplify, or we rewrite this equation. So we have 13 is equal to 34 minus 3t, and or we could rewrite this further. So we will have 3t is equal to, I'll be moving this to the other side of the equation, and this one 13 to that side, so we'll have 34 minus 13, and this is going to give us 3t is equal to 21. Divide both sides by 3, so our time is equal to 7.0 seconds. So 21 divided by 3 is 7.0 seconds, and that is letter B. When a ball is thrown vertically upward, its acceleration at the highest point is, so when we are throwing an objects as they go up, they would slow down, and when they reach to this point, the velocity is equal to 0, and then it starts going down. But this is something that we need to take note. Along the path of the ball, whether it goes up or it goes down, the acceleration is always negative 9.8 meter per second square, and the negative sign here tells us that the object is always accelerating downward, and therefore the answer to this question is letter C. Which of the following correctly describes the motion in the velocity time graph below? So we have here an object with a certain initial velocity, and then the velocity becomes 0 at this point. So at that point, v is equal to 0. So if we look at that point, speeds up, so therefore this cannot be an answer. It slows down, so this is a potential answer. It speeds up, this is also not an answer, because again the velocity actually approaches to 0, then slows down, so therefore we're actually left with B and D. But let's look into the rest of the statements. With a constant positive acceleration now, remember that we could actually solve for the acceleration in a velocity time graph by looking at the slope, and the slope in this case is actually negative. So this gives us a negative slope. If it was a positive slope, then the graph should actually look like this. So here we have a positive slope, and again the slope of a velocity time graph, the slope is acceleration. So therefore acceleration, therefore B cannot be an answer, because it says constant positive, and it's not a positive acceleration, it's actually a negative acceleration, and that gives us that the correct answer for this question is D. So it slows down at this point, becomes 0, then speeds up with a constant negative acceleration. Here the object's velocity is negative, therefore it's moving towards a different direction. So the correct answer in this case is letter D. Slows down, stops, so it slows down, it stops here, and speeds up with a constant negative acceleration. A person drops a small stone in a well which takes 2 seconds to reach the bottom. How deep is the well? Now in this case, it seems like we're only given one quantity, but the word drops simply means that the initial velocity of the object is equal to 0 meter per second, and since it's actually falling, we also have the acceleration, which is equal to g, and that is equal to negative 9.8 meter per second square. And it's asking us how deep is the well. So deep is actually related to displacement. So what equation are we going to use to solve for displacement if we have our initial velocity and the time it takes to reach the bottom? So we actually have delta y is equal to VIT plus GT squared over 2. Let us use this equation. So it's the second equation, and we are going to solve for delta y. We have initial velocity, we have time, we have acceleration due to gravity. Alright, so delta y is equal to, our initial velocity is 0 multiplied by time, which is 2 seconds, plus acceleration due to gravity is negative 9.8, but in this case we could use 10, negative 10 that is, multiplied by the square of the time, so that's 2 squared divided by 2. This whole quantity here becomes 0, so our delta y is equal to negative 10 times 2 squared is 4 divided by 2, and this would give us negative 40 divided by 2. Negative 40 divided by 2 is equal to negative 20 meters. So the negative sign here means that the object is falling. So it has fallen a distance of 20 meters, and that gives us letter C. Which of the following statements are true regarding electric charges? So statement number 1, like charges attract. It's wrong because like charges repel. Second statement, opposite charges attract. This is correct. Third statement, if a neutral object gains an electron, it becomes negatively charged. It becomes positively charged. It's wrong because this should be negative. When an object gains an electron, which is a negatively charged particle, it becomes negative because electron again is negatively charged. Next, if a neutral object loses an electron, it becomes positively charged. Now this is correct because if you lose an electron, which is a negatively charged particle, then you will become less negative, or in this case the object could become positively charged. So therefore, which statements are true? So we have statement number 2 and statement number 4, and that gives us letter D. Which of the following materials is an electric conductor? Now, glass is not a conductor, it's an insulator, also plastic and rubber. Now, so even if you don't know what graphite is, then this should actually tell you that graphite is the answer by virtue of deductive reasoning. However, graphite is a conductor, and this is actually the material that composed the lead of your pencil, and it is a conductor. Which of the following circuits can be used to measure the electric current and voltage of a lamp L? So when we say electric current, the instrument that we're going to use here is an ammeter, and an ammeter in a circuit can be symbolized with this, and it should be connected in series with the resistor, or in this case with the lamp. Now, to measure the voltage, we're going to use a voltmeter, and the symbol of a voltmeter is just like this, and this has to be connected in parallel with the lamp. So if we are going to look at choices A, B, C, and D, only A would actually be correct because we have the lamp here, and the lamp is connected parallel to the voltmeter and series with the ammeter. If you look at B, the lamp and the voltmeter are in series. That makes it wrong. Also here for part C, the lamp and the voltmeter, they're also connected in series, so that's wrong. And also in part D. So again, remember that to solve or to measure electric current, the ammeter should be connected in series, and to measure the voltmeter should be connected in parallel to the electrical component that we would want to measure the voltage for. Which of the following statements below is or are true for alternating current? So alternating current, statement number 1, the voltage level reverses periodically. So this is actually correct because as the current reverses, the voltage also reverses, so it goes back and forth. It goes like this. Current is steady in single direction, so this is wrong because this is the characteristic of a direct current. Now for statement number 3, produced by a loop of wire spun inside a magnetic field. This is actually correct, and this is actually how we could do magnetic induction. So electromagnetic induction produces alternating current. So that tells us that our correct answer is statements 1 and 3. So in this case, it's letter B. A conducting wire of radius r has a resistance r, while another wire of the same material and length has a radius 3r. What is its resistance? So recall that resistance is equal to resistivity times L over area, and area is equal to pi r squared. So we have resistivity is resistance is equal to resistivity over A times pi r squared. So it says here, if the radius is equal to r, then the resistance is equal to capital R. So if the radius is this r here, small r, then the resistance is a capital letter R. So what happens if the wire has the same material, therefore resistivity is the same, and the length is also the same, but our radius is 3r. So we will have, what would our R be? Let's put it here. Resistivity is the same, length is the same, divided by pi, and our R is 3r squared. So let's rewrite this. This becomes resistivity times L over pi. 3r squared is equal to 9r squared. Let us rewrite this. We have resistivity over L times 9 pi r squared. And remember, this quantity here, or this term, rho L pi r squared, is actually this, rho L pi r squared, and this is equal to R. So therefore, our resistivity would just be equal to R over 9. And this is letter A. The diagrams below show two conducting spheres in contact with each other. With a negatively charged object close to them, the spheres are separated. Identify the charges on A and B after the separation. So here we would want to know what the charges on spheres A and B would be. Alright, so in this case, it's neutral. Now we have a negatively charged object over here. So therefore, the negative charges would be moving away from this negative charge here. So we have a positive charge particle, positive, and positive. So if we start with positive, negative, we have positive, negative here. So the negative charges would move away from this negatively charged object here. And then after that, then positive charges stays here, the negative charges remains here. So we have, alright, so basically A would become positive and ball B gains the negative charges of ball A, so therefore this object has more negatively charged particles or electrons compared to the protons, and this makes it negative. So this one here is negative and ball A is positive, and this gives us the answer as letter A. So charges on A is positive while charges on B is negative. Calculate the current flowing in a circuit if 3.0 times 10 to the power of 21 electrons pass through a point in the circuit every minute. So we need to solve for current, which is I, and we are given here 3.0 times 10 to the power of 21 electrons. So this is the number of electrons n, and through a point in the circuit every minute. So we actually have our time. That's our time is equal to 1 minute or 60 seconds. So we have our equation I is equal to Q over T, and what Q is equal to NE over T. So therefore we have I is equal to NE over T. So our N is equal to 3.0 times 10 to the power of 21 multiplied by E, which is the unit of elementary charge. So E is equal to 1.6 times 10 to the power of negative 19, and it's an electron, so therefore we could have negative 1.6 divided by time is equal to 60 seconds. Alright, so we have 3.0 multiplied by negative 1.6. It's going to give us 4.8. It's going to give us 4.8 times, let's look at the exponent, 10 to the power of 21 times 10 to the power of 19. So we actually have to add the exponents. So that's 21 plus negative 19. That gives us 10 to the power of positive 2 divided by 60. Again, let us repeat that. The way to do this, that's 3.0 times 1.6. That gives us negative 4.8. Then 10 to the power of 21 multiplied by 10 to the power of negative 19. That's going to give us 10 to the power of positive 2 divided by 60. So we could rewrite this further. Negative 4.8 times 10 to the power of 2 divided by 60. Now negative 4.8 times 10 to the power of 2 may be written as negative 480 over 60. Again, take note, 4.8 times 10 to the power of 2 is just equal to 480. And this gives us 480 divided by 60. That would give us a negative 8 ampere. But since we could just ignore this negative sign, then our I is equal to, therefore I is equal to 8 ampere. Again, we could ignore the negative sign because it's just talking about current, and the number of electrons cannot be negative as well. So therefore I is equal to positive 8 amperes. A man drops a ball A down from a roof of a tower of height 400 meters. At the same time, another ball B is thrown up with a velocity of 50 meters per second from the bottom of the tower. The balls meet at a point P after time t seconds. Question A. Write an equation in the simplest form, substituting any known values for the distance h1 traveled by A to reach P. So basically, we would want to write an equation for h1. So since the object is just being dropped from since ball A is just being dropped from this point here, then we could say that the initial velocity of ball A, say VAI, is equal to 0 meter per second. So H would be H1 would be equal to VIT plus 1/2 GT squared, and our VIT is equal to 0 times time plus 1/2 GT squared, so that's 1/2. Our G is -10 T squared. So therefore our H1 is equal to 0 plus -5 T squared. We could simplify this further. H1 is equal to -5 T squared. Now take note that H1, or the object, actually traveled down. So therefore our H1 should actually be negative. So we can say negative H1 is equal to -5 T squared. Again, the negative sign here tells us that the object is falling. That's why the H is negative. Part B, write an equation in the simplest form, substituting any known values for the distance traveled by H2 distance H2 traveled by ball B to reach P. Now H2 should be positive because the ball is being thrown upward, so we could just say H2 is equal to VIT of ball B plus 1/2 GT squared. So our H2 would be equal to, the initial velocity of ball B is actually 50 meters per second, so we say, and that should be positive because it's being thrown up, so that's 50 T plus 1/2. Our G is -10 T squared, so we could simplify this further. Again, H2 should be positive because the ball is moving upward. We have 50 T minus 5 T squared, and this is our equation for the height traveled by ball B, or H2. Solve the equations from parts A and B to find the time taken for the balls to meet at point P. So we have here H1 plus H2 should be equal to 400. Now we had our H1 to be equal to -5 T squared, so we could say that H1 is equal to 5 T squared. We also had H2, which is equal to 50 T minus 5 T squared. So let's substitute these two equations in H1 plus H2 is equal to 400. So our H1 is equal to 5T plus our H2, and this is our H2, so plus 50T minus 5T squared. So that's our H1 plus H2 is equal to 400. So 400. And let's simplify this equation. 5T squared, which is our H1, minus 5T squared here, so that cancels out. So we have 5T is equal to 400. Let's divide both sides by 500 to solve for T. And T is equal to 8 seconds. And this answers part C. Find the values of the distances H1 and H2. So again, our H1 is equal to 5T squared. So therefore, let's substitute the value of T, which we have solved in part C. So that's 5 multiplied by 8 squared. So that's H1 is equal to 5 times 64, and this is equal to, so 5 times 64 is equal to 320 meters. Our H2 is equal to 50t minus 5t squared. So we have 50 times 8 seconds is minus 5 times 8 squared. So we have H2, 50 times 8 is equal to 400 minus 5 times 8 squared, or 64, which is similar to H1, that is equal to 320. So our H2 is equal to 80 meters. A motorcycle initially moving with a speed of 4.0 meters per second speeds up at a constant rate to 6.0 meters per second after covering a distance of 5.0 meters. What is the acceleration of the motorcycle? So we have initial velocity, we also have final velocity, and we're given the distance traveled, or delta x, since this is horizontal motion. What is the acceleration? To solve for this acceleration, we're going to look at the three equations of motion, and the equation of motion that has vi, vf, and delta x, and acceleration is the third equation, which is vf squared is equal to vi squared plus 2a delta x. So we have our final velocity. Let's substitute the values. That's 6.0 squared multiplied by initial velocity, which is 4.0 squared plus 2. Then we need to solve for acceleration a, and the distance traveled is 5.0. So let's simplify this. This is equal to 36 is equal to 16 plus 2a times 5, so that's 10a. So we will have minus 16 on both sides. So 36 minus 16, that's 20, is equal to 10a. Divide both sides by 10. So our acceleration is equal to 2 meters per second squared. That's our acceleration. Let's express it with proper significant figures. So acceleration is equal to 2.0 meters per second square. This is the answer to the acceleration of the motorcycle. A bullet is shot straight up, returns to its starting position in 10 seconds. What is the initial speed of the bullets? If we're going to illustrate this, the bullet is actually being shot up with a certain initial velocity. It goes up and then it reaches its maximum height here where the velocity is 0, and then it goes back down to this position, and it takes it 10 seconds. Now at this point, our final velocity is just equal to the negative of the initial velocity. So for example, if the initial velocity is 5 meters per second because it's being shot straight up, so the final velocity is negative 5 meters per second, but we don't really know what that velocity is, so that speed is. So let's solve for it. We know we have the equation vf is equal to vi plus gt, and we know that vf is just equal to the negative vi. So we have vf is negative vi is equal to vi plus gt. Let us simplify this. We will have negative vi. I will move negative vi to the other side, so that will become minus vi is equal to gt. Simplifying this further, the left side of the equation becomes negative 2vi is equal to gt. So let's substitute our values. Negative 2vi is equal to, our g is negative 10 multiplied by the time it takes to complete this flight, and that is equal to 10 seconds. So this is our time here, and we'll have negative 2vi is equal to negative 100. So we'll divide both sides by 2, negative 2 rather. So we will have vi is equal to 50 meters per second, and this is the initial velocity of the bullet. What is the maximum height reached by the bullet? Now, for part B, there are so many ways to solve this equation, but let's use the second equation of motion to solve for part B. You could also use the third equation, by the way, but let's use the second equation, which is delta y is equal to VIT plus 1/2 GT squared. So at the maximum height, we know that the velocity is 0, and if it takes 10 seconds to go from this point, it goes up and then it goes back to initial position. It takes it 10 seconds. Therefore, how long would it take for the ball to reach this height, which is 1/2 of the path? So therefore, the time it takes for the ball to reach the maximum height should actually be equal to 5 seconds, which is half of the time it takes for the ball to complete the entire flight as it goes up and then down. So if it takes it 10 seconds, half of the time would be at the maximum height. So time is equal to 5 seconds, and this is the time to solve that we use to solve for part B. So the maximum height, which is delta y, our initial velocity is what we have solved for part A, and that is 50 multiplied by time, which is 5 seconds, plus 1/2. G is equal to -10, and our time again is 5 seconds, so that's 5 squared. Delta y is equal to 50 times 5, that is equal to 250, plus 1/2 -10 times 25. Delta y is equal to, so that's 250 plus 1/2 times 10 is -5, -5 times 25. Let us simplify this further. Delta y is equal to 250 plus -5. -5 times 25 is equal to -125. So delta y is equal to 250 plus -125 is equal to +125 meters, and this is the maximum height reached by the bullet. Two conducting spheres A and B carry initial charge of 5.8 coulomb and -6.4 coulomb respectively. If A and B are now connected by a conducting wire, what is the net charge on a system AB when connected? So when we say net charge, it's just actually the sum of charge. So this means very easily we could say the charge of A plus the charge of B, that would become the net charge or the net Q. So we have 5.8 plus -6.4, that is equal to net charge, and hence we'll have 5.8 plus -6.4 is equal to 0.6, -0.6, and that this is our net charge. So again, when we say net charge, it is just the sum of the charges that composes our system. Explain the direction in which charges flow. Since B is more negative than A, therefore there are more electrons in B compared to A, so charges would actually be moving from B to A. Again, this is mainly because B has more electrons compared to A, and remember, it is actually the electrons that move around in a circuit because protons are fixed in the nucleus. So explain the direction in which charges flow, that is from B to A. So B to A, because there are more electrons in B. The table below shows the voltage across the current through a material. So we have here the table. When the voltage is 2.0, current is 8.0. When the voltage is 5.0, current is 2.0 times 10 to the power of 1. So that's just the same as 20 ampere. When the voltage is 8.0, current is 3.2 times 10 to the power of 1, or simply 32 amperes. Draw and label the voltage current graph for a material. So if voltage is mentioned first, therefore voltage should be on the y-axis, and here current should be on the x-axis. And in labeling the sides or in assigning the values, the increment should be consistent. So let's start with voltage. We could say if this is 1, this is 2, 3, 4, 5, 6, 7, and 8, and the unit here is volts. The unit on current is ampere. So for current, we have 8, 20, and 32. So we could start here with a 4. Next value should be 8. This should be 12. This should be 16, 20, 24, 28, 32, 36, 40. Again, in graphing, it is very important that the increment is the same, and this is our 0, 0 here. Alright, let's start. When voltage is 2, current is 8. So when voltage is 2, current is 8. So this is our first point. When voltage is 5, current is 20. So when voltage is 5, current is 20. So we have this point over here. Voltage is 5, current is 20. Voltage is 2, current is 8. Next, when the voltage is 8, alright, when voltage is 8, current is 32. Voltage is 8, current is 32. So this point here. Alright, and then we draw a line that would fit all of these points. So basically it's just going to look like this. Alright. So this is our voltage current graph. State with a reason if the material obeys Ohm's law. Yes, because the material obeys Ohm's law because the graph, the voltage current graph, is a straight line and it passes through the origin. Or we could say that the voltage is proportional to current, and this is again the statement of Ohm's law. Next, calculate the resistance of a material. Now, if we are given the voltage current graph, the resistance is just the slope of the graph. So when we say slope, that's just equal to rise over run. So we have the following values. This is rise, that means change in y over change in x. So we could look at the table again. We take two values of y with their corresponding values of x. Then we would be able to solve that the resistance is equal to 4.0 ohms. Next, find the length of the material if it has a cross-sectional area of 1.5 times 10 to the power of negative 5 meters square, and a resistivity of 6.0 times 10 to the power of 8 ohm meters. So resistance is equal to resistivity times L over area. And our resistance is equal to 4, so we substitute that. 4.0 is equal to 6.0 times 10 to the power of negative 8. That's our resistivity. And the length is what we need to solve for in part D, divided by the area, which is 1.5 times 10 to the power of negative 5. So how do we do this? We just have to divide 6.0 with 1.5 first. So we will have 6.0 divided by 1.5. Alright, 6.0 divided by 1.5, that is equal to 4. So let's rewrite this equation. Resistance is equal to 4.0. Now 6.0 divided by 1.5 is just equal to 4.0. Then we have 10 to the power of 8 minus 10 to the power of divided by 10 to the power of negative 5. So if we are dividing terms with the same base, we actually subtract their exponents. So that's going to give us 10 to the power of negative 3, because negative 8 minus negative 5 is going to give us negative 8 plus 5, which is equal to negative 3, and that becomes our exponent here, multiplied by L. So what do we do next? We are going to divide both sides by 4.0 times 10 to the power of negative 3. 4.0 times 10 to the power of negative 3. So we will have 4.0 divided by 4.0, that's 1. And since this is in the denominator, we could put it up and then the sign becomes positive. So that's 1 times 10 to the power of positive 3 meters, and that is equal to L. This is our answer, and we express this in proper significant figures. So L is equal to 1.0 times 10 to the power of 3 meters. This answers question D. Figure 1 below shows a charged electroscope. When a charged rod is brought close to the electroscope, as in figure 2, its leaves separate further apart. What is the type of charge on the rod compared to that on the electroscope? So since it actually caused the leaves to repel, then therefore we could say that the charge of rod is the same as the charge on the electroscope, again for the reason that its leaves, or the leaves of the electroscope, separate further apart. If the electroscope was positively charged, explain why the leaves separated farther when the rod was brought close to it. So this is because if the electroscope was positively charged, therefore the electrons coming from the leaves of here would actually go up towards the electroscope, so leaving the leaves to be more positive. As a result, the leaves separated farther apart. Again, it's because the electrons of the leaves would go up towards the positively charged rod. Draw a circuit diagram of the experimental setup that you would use to verify Ohm's law. Your circuit should include a device to measure current, so this is an ammeter. A device to measure voltage, so this is a voltmeter. A device to change the current in the circuit, so this is a variable resistor. So this is the symbol for a variable resistor. And clearly mark direction of the conventional current. So when we say conventional current, this is the flow of positive charges. Okay, so let's start with the battery. So if this is our battery here, right, that's our battery, this is the positive part of the battery and the negative part of the battery. We will have our variable resistor. So this is actually something that we could use to change the current in the circuit. So we must have an ammeter here, and this ammeter should be connected in series with our resistor, to which we would verify our Ohm's law. And again, in Ohm's law, we just have to look at the relationship of voltage and current. So if this is our resistor here, then we could connect our voltage to across our resistor. It should be connected in parallel. Now clearly mark direction of the conventional current. So conventional current again is the flow of positive charge, so therefore conventional current goes this way, up, then towards the resistor, down. So that's our conventional current. And that concludes this tutorial. I hope you learned something. Always remember, physics is easy with Mr. Jesse.